April 15, 1943, 20,000 feet over the French coast near Dieppe, Major Donald Blakesley's leather-gloved hand tightened on the control stick as he spotted the familiar silhouette emerging through the clouds below. After weeks of frustrating training flights and mechanical issues with the new Republic P-47 Thunderbolts, the 4th Fighter Group was finally confronting the enemy. The massive American fighters, which British pilots had derisively nicknamed 7-ton milk bottles, were about to demonstrate their true capabilities. Through his gunsight, Blakesley tracked a Focke-Wulf 190 of JG-26 Schlage, unaware that he was on the verge of making history. At 300 yards, he pressed the firing button. 8 Browning .50 caliber M2 machine guns roared simultaneously, each firing at 800 rounds per minute. The combined firepower, 6,400 rounds per minute in theory, sent a concentrated stream of armor-piercing incendiary rounds into the German fighter. The Focke-Wulf, pride of the Luftwaffe with its 220mm MG-150-120 cannons and two 7.92mm MG-17 machine guns, disintegrated in seconds. This was the P-47's first aerial kill, signaling the start of a transformation in fighter combat doctrine. The Americans had not merely built a fighter, they had created an airborne weapons platform that redefined firepower through industrial scale. The story began months earlier. The P-47's first operational mission took place on March 10, 1943. When the 4th Fighter Group conducted a fighter sweep over France. Radio failures plagued this initial sortie, forcing a return to base and the installation of British radio gear. Throughout early 1943, the 4th Fighter Group, formerly the RAF's Eagle squadrons, struggled with the transition from nimble Spitfires to the massive Thunderbolts. The P-47 weighed 12,731 pounds empty, rising to 17,500 pounds fully loaded, more than twice the weight of a Messerschmitt Bf 109G. Republic Aviation's Farmingdale, New York factory was producing these giants at unprecedented speed. By April 1943, one P-47 was rolling off the line every 4 hours, with production accelerating each month. Alexander Kartveli, the Georgian-born chief designer, approached fighter development with a philosophy that seemed absurd to European engineers: maximum firepower delivered through maximum output. Where German designers obsessed over tiny weight savings, Kartveli added guns, ammunition, and armor. Colonel Hubert Zemke, commanding the 56th Fighter Group, understood the American approach. His unit had arrived in England in January 1943 and was flying combat missions by April. The 56th would become the only 8th Air Force Fighter Group to operate P-47s exclusively throughout the war, ultimately claiming 674 aerial victories. The P-47's firepower was mathematically straightforward. Early P-47C and P-47D models carried 350 rounds per gun, 2,800 rounds in total. The 8 guns, 4 per wing, created a convergence zone at 250 yards where all bullet streams intersected. Within that zone, the density of fire surpassed anything previously seen in single-engine fighter combat. A 1-second burst delivered 107 half-inch projectiles, each traveling at 2,840 feet per second. Luftwaffe intelligence initially dismissed reports of the P-47's armament. 8 heavy machine guns on a single-engine fighter seemed impossible. German doctrine emphasized efficiency, minimum firepower to destroy enemy aircraft, conserving weight for performance. The Focke-Wulf 190A5, the main Luftwaffe fighter in Western Europe in spring 1943, carried two 7.92mm MG-17 machine guns with 1,000 rounds each and two 20mm MG-150-120 cannons with 250 rounds each in the wings. Though the 20mm shells were more destructive than .50 caliber bullets, the limited ammunition supply demanded precision. German pilots had developed attack techniques relying on short, accurate bursts at close range, effective against British Spitfires and Hurricanes with their limited armament. After Blakesley's first victory, encounters between P-47s and German fighters increased rapidly. On April 17, the 4th Fighter Group flew its first bomber escort mission. Though early drop tank designs limited range and forced an early return, the psychological effect on German pilots was immediate. The 8 guns produced a visual spectacle unlike anything they had faced before. Standard P-47 ammunition included 4 armor-piercing incendiary rounds and 1 tracer every 5th round, creating the appearance of a continuous beam of light. By May 1943, captured P-47 components were being studied at the Luftwaffe's test center. German engineers found that the Browning M2, despite being a 1933 design, had been refined through mass production to unprecedented reliability. Parts were fully interchangeable, any component from any gun fit perfectly in any other, a level of standardization German industry could not achieve. The ammunition feed used disintegrating link belts that ejected cleanly from the aircraft. German fighters relied on drum magazines of 60 to 200 rounds or belts that retained links, adding weight and complexity. American reliability allowed pilots to fire their full ammunition load in one continuous burst if needed. The scale of American ammunition production stunned German analysts. By mid-1943, the 8th Air Force flew over 200 P-47 sorties daily, each carrying 2,800 rounds, typically using 60% of their ammo. That amounted to roughly 336,000 rounds fired daily, more than the entire German fighter force in France received in a week. The Lake City Army ammunition plant in Missouri had reached an annual output of 1.66 billion rounds by 1943. Surpassing Germany's entire small arms industry. The facility operated non-stop with 20,000 workers across shifts, maintaining strict quality control with tolerances of 0.001 inch. Republic Aviation's production was equally impressive. The Farmingdale plant spanned 765,000 square feet, with additional production at Evansville, Indiana. Combined output exceeded 400 P-47s per month by late 1943. While German fighter production struggled to surpass 1,000 per month. German fighter doctrine favored lightweight, maneuverable aircraft. The Bf-109 G6 weighed 6,940 pounds fully loaded, the Focke-Wulf FW reached 9,040 pounds, while the P-47C tipped the scales at 13,500 pounds loaded. The P-47D reached 14,500 pounds, impossibly heavy by German standards. Yet the P-47's Pratt & Whitney are 28,000 double wasp engine producing 2,000 horsepower initially and 2,300 in later models provided competitive power-to-weight ratios. The weight provided stability as a gun platform and ability to absorb tremendous damage. The General Electric Turbo Supercharger system weighed 845 pounds alone, nearly the entire armament weight allowance on German fighters, but it maintained full power at 30,000 feet altitudes where the BMW 801 radial engine in the FW190 lost significant power above 20,000 feet. The shock of facing P-47 firepower forced immediate Luftwaffe tactical changes. Traditional attack methods became suicidal when P-47s were present. American fighters didn't need optimal firing position. Their volume of fire created kill zones. German fighters couldn't survive crossing. Luftwaffe units developed new tactics emphasizing the FW-190's superior roll rate and turning ability at low altitude, but reaching low altitude required diving through the P-47's fire envelope. American pilots learned to use altitude advantage and firepower to force German fighters into unfavorable positions. The contrast in ammunition philosophy was stark. German pilots entered combat with 60 to 90 seconds of firing time. P-47 pilots had 30 to 35 seconds of continuous fire available. This disparity created fundamental tactical differences. Germans conserved ammunition while Americans fired liberally. August 17, 1943, the first Schweinfurt-Regensburg mission demonstrated both P-47 capabilities and limitations. Within escort range, P-47s devastated German interceptors. The 56th Fighter Group alone claimed 17 victories without loss. But P-47 range? Even with 75 gallons belly tanks, limited escort to roughly 375 miles from base. German tactics evolved to exploit this limitation. Luftwaffe controllers waited until P-47s departed before launching attacks. The resulting bomber losses, 60 B-17s, highlighted the need for longer range. But within the P-47's protective envelope, bomber losses approached zero. Introduction of 108 and later 150 drop tanks progressively extended range. By October 1943, P-47s could escort bombers 425 miles from base. Each extension meant German fighters had to wait longer and fly farther before engaging. The infrastructure supporting P-47 operations reached industrial scales that defied German comprehension. Each P-47 squadron maintained reserves of 500,000 rounds. Forward airfields in England stockpiled millions of rounds. Supply ships delivered ammunition continuously from American factories. A typical P-47 group possessed enough ammunition for 30 days of maximum intensity operations without resupply. German fighter units operated on 3-day reserves, often less. American pilots fired liberally while German pilots counted every round. Maintenance supplies showed similar disparity. American depots maintained complete replacement engines, gun sets, and major components. Damaged P-47s could be rebuilt from spare parts in days. German units cannibalized damaged aircraft for parts, reducing operational strength even when airframes could theoretically be repaired. October 14, 1943, Black Thursday, the second Schaubine raid marked a turning point. While P-47s flew escort to maximum range, claiming 21 German fighters, bombers faced devastating attacks after escorts departed. German pilot reports revealed growing concern about engaging P-47s. The mathematics were irrefutable. A German fighter squadron staffel of 12 aircraft might possess 7,000 rounds, total of mixed calibers. A single P-47 squadron of 16 aircraft carried 44,800 rounds of heavy machine gun ammunition with millions more in reserve. The firepower advantage was amplified by training differences. American P-47 pilots arrived in combat with 400-plus flight hours, including 100-plus hours of gunnery training. They had fired thousands of practice rounds at targets. German pilot training by late 1943 averaged 110 flight hours before combat, with perhaps 20 hours of gunnery training. Fuel shortages meant many German pilots entered combat having fired their guns only a few times. They faced American pilots who had expended more ammunition in training than German pilots would fire in their entire combat careers. Lieutenant Colonel Francis Gabi Gebreski, who would become the leading P-47 ace in Europe with 28 victories, described the tactical reality. We didn't need to be better shots. We needed to put our sight on them and hold the trigger down. 850s did the rest. By November 1943, P-47 groups began emphasizing ground attack after escort duties. The 850 caliber guns proved devastating against locomotives, vehicles, and parked aircraft. Armor-piercing incendiary ammunition could penetrate locomotive boilers and vehicle armor. A single P-47 could destroy an entire train in one pass. The standard attack profile involved a 30 degrees dive, opening fire at 1,000 yards, walking rudder pedals to spray bullets across the target, pulling out at 200 feet in 10 seconds. A P-47 could deliver 800 to 1,000 rounds into a target area 100 yards long. German transportation networks faced systematic destruction. P-47s destroyed locomotives faster than German industry could replace them. By December 1943, German units avoided rail movement during daylight due to P-47 interdiction. The P-47's role in the strategic bombing campaign proved crucial. While the P-51 Mustang would eventually assume the long-range escort role, P-47s provided the initial shield that allowed the bomber offensive to continue despite heavy losses. By early 1944, improved P-47D variants carried 425 rounds per gun, 3,400 rounds total. The P-47D-25 introduced a bubble canopy, paddle blade propeller, and provisions for rockets in addition to guns. These improvements maintained the P-47's combat effectiveness even as German fighters improved. June 6, 1944, D-Day provided the ultimate demonstration. P-47s flew 2,398 sorties, claiming 84 German aircraft destroyed in air and 89 on ground. More significantly, they paralyzed German ground movement through interdiction. The Luftwaffe managed only 319 sorties over Normandy on D-Day. Americans flew over 13,000. German fighters over Normandy possessed perhaps 200,000 rounds total. American fighters carried millions of rounds with unlimited resupply. P-47s created free fire zones where anything moving was destroyed. Vehicle columns were reduced to burning wreckage in single passes. The distinctive whistling sound of diving P-47s, air flowing through gunports and cooling ducks became a terror weapon. By late 1944, German fighter production actually peaked at 25,000 annually. But fuel shortages, pilot losses, and overwhelming Allied numerical superiority meant most never flew operationally. Those that did faced odds exceeding 10 to 1. The Messedny 262 jet fighter provided speed advantage, but not firepower superiority. Its 430 million Malawian Kwacha's 108 cannons carried only 80 to 100 rounds per gun, 360 rounds total. While devastating against bombers, limited ammunition and low muzzle velocity made them less effective against fighters. The P-47N, introduced for Pacific operations, carried 550 g internal fuel. This single-seat fighter carried more fuel than German medium bombers, demonstrating American industrial capability to build aircraft that defied conventional limitations. Final production numbers tell the story. Total P-47 production 15,683 aircraft. Peak monthly production over 400 aircraft combined plants. Total FW-190 production approximately 20,000, all variants 1941 to 1945. FW-190 fighter variants approximately 13,000. Each P-47 was fully equipped with 8 guns and adequate ammunition. German fighters increasingly flew with reduced armament due to shortages. By 1945, some FW-190s operated with only 2 cannons instead of 4 to conserve ammunition. Republic Aviation's facilities covered over 1 million square feet of production space. German fighter production operated from frequently bombed facilities with dispersed production, reducing efficiency. Lake City Army Ammunition Plant alone produced 1.6 billion rounds annually. Combined with other facilities, Frankfurt Arsenal, Des Moines Ordnance Plant, Twin Cities Ordnance Plant, American production exceeded 10 billion rounds of .050 caliber ammunition. During the war, German ammunition production for all aircraft weapons totaled approximately 4 billion rounds, including all calibers combined. Americans produced more rounds of their single heavy machine gun caliber than Germany produced of all aircraft ammunition types together. Quality control differed dramatically. American ammunition underwent multiple inspections with 2 to 3% rejection rates. German production, increasingly relying on slave labor and substitute materials, experienced higher malfunction rates that reduced effective firepower. The U.S. Strategic Bombing Survey documented P-47 achievements in Europe. 3,916 enemy aircraft destroyed in aerial combat. 32 enemy aircraft destroyed on ground. 9,000 locomotives destroyed. 86,000 railway cars destroyed. 68,000 motor vehicles destroyed. 6,000 armored fighting vehicles destroyed. These statistics represent strategic impact beyond tactical success. Transportation infrastructure destruction by P-47s significantly reduced Wehrmacht mobility and logistics. The Luftwaffe's inability to counter P-47 ground attacks meant American air power operated with near impunity. American pilots who completed 25 mission tours, later extended to 35, then 50, rotated home to train new pilots. German pilots flew until killed, captured, or incapacitated. By late 1944, most Luftwaffe pilots were novices facing American veterans. The experience gap widened continuously. American training programs incorporated combat lessons immediately. German training disrupted by fuel shortages and abbreviated by necessity produced pilots with varying skill levels facing standardized American tactics. Beyond firepower, P-47s incorporated technologies enhancing effectiveness. The turbo supercharger allowed full power at extreme altitudes. The R-280's reliability meant consistent performance with 400-hour intervals between overhauls. The K-14 gun sight introduced computed deflection automatically using gyroscopic principles. Pilots simply framed targets and fired. German fighters used reflector sights requiring
Manual deflection estimates.
Gun heating systems prevented freezing at altitude. P-47 guns functioned reliably at 40,000 feet in -60 degrees Fahrenheit temperatures. German fighters frequently experienced gun freezing above 25,000 feet, particularly wing-mounted weapons. American abundance extended to maintenance. P-47 groups maintained extensive spare parts, complete engines, gun sets, propellers. Ground crews could completely re-engine aircraft overnight. Battle damage requiring weeks of German repairs was fixed in days. German maintenance became increasingly problematic. Spare parts shortages meant cannibalization. By late 1944, Luftwaffe serviceability dropped below 50. American P-47 groups maintained 85% serviceability rates routinely. American crew chiefs were trained specialists with extensive technical education. German ground crews, depleted by conscription, increasingly consisted of foreign workers and Hitler Youth with minimal training. P-47s burned 100/130G grade aviation fuel, allowing higher manifold pressures and increased power. German synthetic fuel from coal provided inconsistent octane ratings, reducing performance and reliability. By late 1944, German fighters received 30 to 50 gall per sortie when available. P-47s routinely carried 370 gallons internally, plus external tanks. American pilots flew multiple daily missions, while Germans were grounded by fuel shortages. German pilots knew aggressive maneuvering consumed precious fuel needed for return. American pilots flew without fuel anxiety, enabling aggressive tactics Germans couldn't match. The P-47 represented American industrial philosophy, overwhelming quantity of sufficient quality. Where Germans pursued technical perfection in limited quantities, Americans pursued adequate performance in unlimited quantities. Cartveli's design prioritized producibility over optimization. The P-47 was easier to manufacture than German fighters despite greater complexity. Standardization and mass production meant faster production at lower cost. This philosophy extended throughout the supply chain. The same 50 caliber rounds fired by P-47s were used by bombers, ground vehicles, and naval vessels. This simplified logistics while achieving economies of scale impossible with diverse calibers. German attempts to match American firepower proved futile. The FW-190A8, introduced February 1944, could carry additional cannons in underwing pods, but added weight and drag severely degraded performance. The Sturmbach variant, optimized for bomber destruction with heavy armor and 30 mm cannons, was helpless against escort fighters. The fundamental problem was industrial capacity. Germany could not simultaneously fight a multi-front war and match American production. Attempting to do so only accelerated resource exhaustion. Beyond physical destruction, P-47s achieved psychological victory. The distinctive whistle of diving P-47s became a terror weapon. German soldiers developed persistent anxiety about P-47 attacks, diving for cover at any aircraft sound. American pilots understood their psychological advantage. They flew with confidence from unlimited resources. German pilots flew with desperation from scarcity. This mental state affected tactical decisions, with Germans increasingly avoiding combat unless necessary. The P-47 achieved a 4.6 to 1 6 to 1 kill ratio in over 746,000 sorties, while 3,499 P-47s were lost to all causes. This represented less than 0.5% loss rate per sortie. German fighter units suffered 50% monthly casualties by late 1944. The 56th Fighter Group, flying only P-47s throughout the war, became the top scoring American fighter group in Europe with 674 aerial victories. This demonstrated that supposed P-47 limitations were overcome by firepower, durability, and pilot skill. The P-47's 850 caliber guns represented more than firepower. They embodied American industrial philosophy triumphant.
Each gun required precision manufacturing and complex supply chains that America could mount 8 per
fighter with ammunition to sustain them demonstrated industrial supremacy, transcending military calculations. Military historians recognize P-47 firepower as decisive in achieving air superiority over Europe. The ability to deliver overwhelming firepower at extended ranges broke the Luftwaffe's defensive capability. Once air superiority was achieved, Allied victory became inevitable. The P-47's influence extended beyond World War II. It established principles dominating modern air combat: firepower, superiority through volume of fire, standardization, enabling mass production, and industrial capacity, determining military capability. Modern fighters carrying rotary cannons, firing 6,000 rounds per minute, are direct descendants of the P-47's philosophy. Precision-guided munitions represent evolution, not rejection, of the firepower principle, another form of overwhelming force through industrial superiority. When West Germany rebuilt its air force in the 1950s, it adopted American equipment, tactics, and doctrine. German pilots trained on American aircraft, fired American ammunition, absorbed American philosophy. The student learning from the master. While statistics tell the strategic story, individual accounts reveal the human dimension. Colonel Robert S. Johnson of the 56th Fighter Group survived an attack on June 26, 1943. That put over 200 bullet holes in his P-47. The aircraft absorbed damage that would have destroyed any German fighter, flying home with controls damaged and canopy shattered. Colonel Hubert Zena, commanding the 56th Fighter Group, developed tactics maximizing P-47 advantages. His ZMI fans spread squadrons wide, creating overlapping fields of fire German fighters couldn't penetrate. Under his leadership, the 56th achieved remarkable success exclusively with P-47's German pilot Heinz Kanoki, author of I Flew for the Führer, described facing P-47s as confronting streams of tracers. That seems solid, making bomber approaches through escort screens impossible. His memoir provides valuable German perspective on American firepower superiority. Behind statistics were millions of American workers producing the arsenal of democracy. At Republic Aviation's Farmingdale plant, women comprised 40% of workforce by 1943. These workers built P-47s with precision exceeding PCM standards while maintaining unprecedented production rates. The Lake City ammunition plant operated non-stop, with workers producing billions of rounds in climate-controlled facilities. Quality control inspectors, predominantly women, rejected any rounds that deviated even slightly from specifications. Their dedication ensured American pilots never suffered the ammunition failures that plagued German fighters. American workers earned solid wages, lived comfortably, and took pride in their contributions. In contrast, German production increasingly relied on forced labor under deteriorating conditions, resulting in sabotage and declining quality. The P-47 program cost roughly $1.3 billion in 1940s dollars, a massive investment in a single weapons system. Yet, American industrial capacity made this feasible while simultaneously producing thousands of other aircraft, tanks, and ships. Mass production continuously lowered unit costs. Early P-47s exceeded $100,000 each, but by 1945, costs had dropped to $83,000 despite enhanced capabilities. German fighter production costs, meanwhile, rose throughout the war as dispersed manufacturing and material shortages reduced efficiency. Post-war analysis highlighted the gap between American and German production methods. American factories employed specialized machine tools, assembly line techniques, and statistical quality control, while German factories relied on craft methods unsuited to mass production. The Browning M2's design facilitated large-scale manufacture, simple, durable components produced by semi-skilled workers using automated machinery. German weapons required highly skilled artisans using traditional techniques. This fundamental difference allowed the US to expand output exponentially, while Germany could not. The P-47's 8 guns exemplified the synthesis of American advantages: industrial capacity, technological innovation, logistical excellence, and superior training. No single factor was decisive, but their combination proved overwhelming. Industrial output provided the foundation, the ability to produce aircraft, guns, and ammunition in vast quantities.
Technology ensured effectiveness, turbocharged engines, reliable power plants, precision engineering.
Logistics delivered materials where needed. Training enabled pilots to exploit these advantages fully. Germany possessed skilled pilots, innovative technology, and tactical sophistication, but without an industrial base to sustain them, these qualities were insufficient. The Luftwaffe was defeated not through superior tactics but by overwhelming material superiority, symbolized by 8 guns firing continuously. German pilots confronting P-47 Thunderbolts learned harsh lessons about modern warfare. Their Focke-Wulf 190s, excellent fighters by traditional standards, were overwhelmed by American firepower produced at scale. Machine guns supplied with nearly limitless ammunition represented a new paradigm in air combat. The transformation from confidence to shock to acceptance mirrored Germany's broader World War II experience. Initial tactical advantages, based on innovation and skill, collapsed under American mass production and material abundance. The P-47, once dismissed as too heavy, proved that industrial might could overcome tactical deficiencies. German pilots were astounded not only by 8 guns firing simultaneously but by what those guns symbolized: a nation capable of producing unlimited weapons, ammunition, and aircraft. The FW-190 might have been superior by traditional measures, but traditional measures had become irrelevant. The P-47's .50s rewrote the rules of aerial combat through sheer industrial power. This legacy persists in every modern fighter, emphasizing firepower over finesse, in every massive expenditure of munitions, and in every industrial approach to military challenges. All trace their lineage to the moment German pilots first faced 8 synchronized Browning machine guns and realized their entire conception of air combat was obsolete. The P-47 Thunderbolt didn't merely outgun the FW-190, it outproduced, outsupplied, and ultimately outthought German aviation philosophy through overwhelming firepower delivered by industrial democracy. These 8 guns were more than weapons. They were heralds of American industrial might. Every burst demonstrated a production capability Nazi Germany could never match. The thunderous roar of 8 synchronized Brownings became the sound of inevitable Allied victory, a sound that echoed from American factories to the skies over Europe, forever transforming aerial warfare.